Yeah, namespace. We already discussed the namespace in the last classes, guys. But you will not understand. So you are not understanding the what is the namespace, right? Today we'll understand the namespace. Something like a namespace is nothing but a. So we can create a namespace, and within the namespace we can create the parts and services. We can create the parts and services. So namespace represent a cluster inside another cluster. Kubernetes components will be grouped logically using namespace. So note we can consider the namespace as a package in Java, something like so we can have a multiple namespaces in Kubernetes cluster. So we can get all the namespaces using the below command. So what is the command, guys? kubectl get namespaces or kubectl get NAS. So what is the command, guys? kubectl get parts, kubectl get no get nodes, kubectl get svc services, kubectl get NS. Get NS or namespaces. So so they have the the default namespaces as default namespace kube system public. So default it will be used by the default when we don't specify our namespaces. Kube system it contains a Kubernetes control plane plot. So kube public it is reserved for the Kubernetes system usage. System usage. The namespace creation, it is recommended to run our pods using the default namespaces. It is not recommended to run our pods using the default namespaces. We have to create our own namespaces to run our pods. So create our own namespace, kubectl create namespace name. For example, the customer app, agent, report, these all are the three microservices. Three microservices are the pods are created under the create the namespace. Under the namespace, we created the services and pods. So we create the service and pods. We will run our pods using the custom namespaces. So how to get the pods belong to a namespaces. So we will run our pods using the custom namespaces. kubectl get pods -n namespace -n namespace. So creating a namespace. How you can create the namespace? kubectl create namespace test app. kubectl get namespaces. kubectl kubectl get pods -n a test app. So we will check it. The other way is we can create the manifest file. Within the manifest file, we can include the namespaces, guys. So if you delete the namespace, all the object resources components also get deleted. Components also get deleted. Yeah, guys. Hmm. New file. New file is nothing but a namespace -svc hyphen pod dot yaml. So this is my namespace, guys. So I will show you. Type in the just we can create a so we created this one, right? Okay, cancel. So I will folder. Yeah. So we will take this, guys. I will take the same just create a right. SVC namespace this one. So this is the same, guys, for creating the pod and load balancing node port. node port, right? Or load balancer, whatever it may be, guys. So whatever it may be, cluster IP, node page, node balancer. So for example, node port, node port, the node port value, we'll specify the node port here, node port 30232. I'm giving the node port number. So node port 30232. Yeah, guys. So here what we mentioned, what we created the pod. So and we created the service. So here only, so we will create the namespace. So we will create the namespace. So what namespace we will create? We will create the mm, what is that, guys? API metadata, just API metadata. So we will take this, we'll take this, we'll take this from metadata, copy, we'll paste it here. So what is this? API version v1, kind equal to, what is the kind, guys? Kind is a name space. Kind is a namespace. So metadata. So metadata, you can provide the metadata, the namespace name. For example, Hari IT NS. So Hari IT NS is nothing but a Hari IT namespace. I'm creating the namespace name, call it as a Hari IT NS. So Hari IT NS, and so every metadata. So in the labels, right? In the metadata, every metadata we need to provide the namespace name equal to Hari IT. So for example, here in the metadata, so we can create the namespace equal to namespace Hari IT NS. So Hari IT NS this is the pod, and we need to provide it in the we need to create it in the under the service also. So this is the what is that, guys? Namespace creation. Namespace creation. Create namespace. Yeah, guys. Namespace pod data aml. So this is the creating pod service under the custom namespace. What it is, guys? Created. So creating pod and service under custom namespace. Under custom namespace. Guys, understood? So we are creating a a custom namespace under the pod and service. So custom namespace under the pod and service. Guys, got it? So what we can include? We can include the API version, the kind. So definitely kind, guys. So kind is nothing but a namespace, kind is nothing but a pod, kind is nothing but a service. So namespace, I'm creating a namespace Hari ITNS namespace. Under the namespace, we want to create a pod and a service. So we want to create a pod and service. Guys, understood? So we want to create a pod and service. So how you can create the namespace using the manifest file? So you can create the namespace using the manifest file, and you can create the namespace by using the namespace create. So we can create. So we can create the namespace. Kubectl create namespace. So Hari IT NS. Guys, understood? So it is highly recommended. It is highly recommended to create our our K8s components. Components means, what are the components, guys? The components are nothing but pod services under custom namespace. Under custom namespace. Guys, got you? Guys, understood? So create a namespace. So we can create namespace by using two types. We can create the namespace in two ways. We can create namespace in two ways. Guys, one is create a namespace. Create a namespace by using the command. What is that, guys? By using the command. The command is kubectl create ns Hari IT ns. So we are creating it. We are creating a namespace by using the command. The second one is, so create a namespace by using the manifest file. By using the manifest YAML file. So what is the YAML file, right, guys? So you can create the. So this is the manifest file for creating the namespace. This is the manifest file for creating the namespace. Guys, after creating the manifest file, what you can do, guys? You can do it by using three dots. So we can do it by using manifest file also. Just for example, so we can create a normal namespace.yaml. So just create the namespace.yaml. So what is the namespace? API version v1 kind namespace metadata just a Hari IT ns. So this is the just namespace.yaml. Yeah, guys, will show you. So how you can create the namespace? How you can create the namespace by using YAML file, guys. Guys, are able to connect to this so are you able to connect to this my GitHub account, right, guys? Guys, are you able to access my GitHub account? Guys, speak code, guys. So I'm losing my concentration. Funny. సో గిట్ హబ్ నా అకౌంట్ యాక్సెస్ చేస్తున్నారా? అది క్లిక్ చేయగానే నా అకౌంట్ వస్తుందా?
వస్తుంది సార్.
ఓకే. Yeah, guys. So what you can do, you can create, you can use this my names, and you can create your own something like own repository, and you can also create these files, guys. You can also create these files. Okay. Yeah, guys. So how you can create our own namespace? What is that? So this is aws.console.sign in. Sign in your console. Root is signing. T appearance change 18 select session login. So this is the one SSH auth credentials browse remote case open Ubuntu. Yeah guys, EKS. What is that guys? kubectl get nodes. Yeah, kubectl get parts. No parts are available, right? So no parts are available. So I'm deleting everything. kubectl delete all all. Service Kubernetes deleted. Yeah guys. So now kubectl get svc. So get svc. So Kubernetes, this is the default one. Kubernetes get ns. You see guys, before already I showed. So the default, whenever you are creating, you are not specifying any namespace, by default it is creating. So Kubernetes nodes, Kubernetes public, Kubernetes system. So if you want to get that kubectl get pods -n namespace. What is the namespace guys? Default namespace. No, the default namespace there is no kube public. So kube public also there is no namespace. Kube system. So those are the system related. Yeah, you see guys. So AWS node, core DNS, kube proxy, these are running. So in this namespace, these all pods are running. So these all pods are running. Yeah, guys. How you can create the namespace by using the so how you can create kubectl create ns ret ns. I'm creating a namespace by using command kubectl get ns. ns is created red ns kubectl create create get parts -n hari it ns. Yeah guys, no resources found in the hari it ns but created. Yeah, I want to delete that namespaces. How you can delete? Kubectl delete ns -n hari it ns resource. How you can delete guys? You can delete. So kube get So yeah, guys, kubectl delete ns. Just no need to provide this one, guys. Just REIT ns, REIT namespace. Yes, guys. So deleted, right? Let's check the ns. ns is not created. So you can create by using the namespace dot aml also. Namespace dot aml. You can use the so we can create by using this, guys. This command. Let's check it. So I'm creating the namespace. API version v1 kind namespace metadata. So metadata name REIT ns. Yeah, just I'm creating the namespace by using the AML file. Kubectl apply -f namespace dot aml. Yes, guys. Kubectl get ns. Get ns. Yes, REIT is created. Right, guys. You can create by using manifest file, or you can create by using the command also. Now, guys, yeah, I'm deleting again, and I will create the namespace in the manifest file. So within the namespace, we can check the parts, guys. So we can check the parts. Yeah. So vi namespace hyphen svc hyphen part dot ml. So I'm creating a name with the namespace, guys. So with the namespace, so we already took this one, right, guys? I'm copying this, guys, and pasting. Yeah, here first I'm creating a namespace called as a REIT ns. The namespace call it as a REIT ns. And then I'm creating a pod. I'm creating the pod my tomcat pod. So within the namespace we create the pod. So within the namespace we create the service, guys. We create the service type equal to node port and selector equal to my tomcat. So where we need to mention it in the metadata. So we need to mention it in the metadata. Guys, understood? So we just need to mention it in the metadata. Metadata. Let's check it, guys. WQ kubectl apply. What is that, guys? Namespace -svc pod dot aml. You see, guys, first namespace is created, then pod is created, then service is created. Yeah, guys. So what is the command to check the pods, guys? Kubectl get pods. Yeah. You see, guys, no RSS is found in the default namespace because of these service and pod created under the namespace Hari ITNS. Right, guys? So we need to check it. So we need to check it in the in the which namespace, guys? So we need to check it in the Hari ITNS. How you can check it? Kubectl get pods -n. What is the namespace? Hari ITNS. Hari ITNS. Guys, you see? So my Tomcat 9 is running. What is that, guys? My Tomcat 9 is running. So -o voida. Yeah. So you will get the uh, IP address of the pod and Which node? Created in the 116 node, we created in the 116, 116 guys. Guys understood? So SVC. So SVC also kubectl get SVC. Kubernetes cluster IP. Just so it is not showing in the, it is not showing the that REIT namespace, that node port namespace, right? But the node port namespace is under the REIT. Let's again -n. So REITNS. You see guys, my Tomcat SVC is created node port, or else so you can use the command kubectl get all -n REITNS. You see guys, pod is running and the service is running with the node port. Service is running with the node port. The IP is 30232. 30232. Guys understood? This is a service creation. Let's check it in the, so what is this guys? Where it is created? It is created under the 16 guys. It is created under the 16. Yeah, so this is the 16. This is the public IP address or public DNS also we can use it. Colon 30232, right? So what is that guys? 30232. Yep guys, Tomcat is, so what is that guys? Lab 6A, right? Yeah guys, it is deployed. So enter the attribute values to find the best lens. So type something like the drop down guys, the drop down. So this is our application. So this is our application. Guys understood? So this namespace in the real time, guys, in the real time, so the pods and services, the deployments, everything will be created under the namespace only. Everything will be created under the namespace only. Guys understood? Yeah. So how you can get the, yeah. So how you can check the logs, guys? kubectl logs pod name. So what is the pod name, guys? My Tomcat, my Tomcat 9. What is that? -n. What is that, guys? REITNS. You see, guys? So these all are the logs. Is there anything error you are getting? Something like a HTTP Neo, X or Apache, Kitlo HTTP server fast request. Note further occurrences, requests are pending. Errors will be logged to the debug level. So these are the logs, guys. So if you want to, we want to check the logs on the pod, you guys can check the logs. Guys understood? Guys understood? Yeah. How you can delete, guys? kubectl delete namespace Ashok ITNS. Sorry, Hari ITNS. So whatever it may be, guys, we can create it funny ITNS or Vinay ITNS. So whatever it may be, you can create it, guys. So you can create it. What is this, guys? Command kubectl create svc or create ns, create name ns. You can create it. It automatically will create it, guys. So you can create by using. You can create by using. We can create by using commands or something like that. We can create ns. So when IT ns or funny IT, so we can create it whatever it may be, guys. Guys, understood now the namespace? Guys, understood or not?
Yes, sir.
Yes, right. Yeah. So this is nothing but a. So this is nothing but the a namespace. How you can create the namespaces under the pods and services. So what we are discussed, guys. Yeah, kubectl create namespace test app. Everything is done, right? Yeah. So node port also, load balancer also we discussed about pod life cycle. Yeah. So we already discussed it, right, guys? So manually created pod is not recommended. So manually created pod is not recommended because of Kubernetes managing everything, right? Managing everything means so it will create automatically. It will create automatically. So if it is if it is dead, if it is dead, but here is it automatically created? So delete hari.ns kubectl get parts -n hari itns. So there is no spaces, right? So we created the pod, but we deleted the pod. So it is not recreating the pods. It is not recreating the pods. The same way, right? Docker also. If Docker container stopped the Docker container, if Docker container is dead, so we need to manually run the Docker container. So the same way, Hari something like the Kubernetes also will doing the same thing, right? But what is the advantage of the Kubernetes? Kubernetes is auto healing capability. So what is that? Auto healing capability means if it is dead, if pod is dead, it automatically create the pod, create the a pod, right, guys? It automatically create the pod. But so we deleted the pod, but it is not created automatically. How it will create? It will create by using the replication controller and replica set. What is that, guys? Replica set and replication controller. The starting they created as a replication controller. What is that, guys? So replica set and replication. So replication set or replication control both are same. So it will if the pod is dead, it automatically start the another pod. It automatically starts the another pod. For example, a replica set. You set as a replica Replicaset, Replicaset 3. So a Replicaset 3, it automatically, if one pad is deleted, it automatically created the 3 pods. So that is nothing but a high availability. What is that, guys? High availability. High availability. So high availability. So we set as a Replicaset 3 or replication controller 3. If the pod is deleted, it automatically creates the pod. It automatically creates the pod, guys. Yeah. So it automatically manually created pod is not recommended. So in the above scenario, we have created the pod manually. It is not recommended. So if we create the pod, then Kubernetes will not provide the high availability. So let's test by deleting our pod. Yeah, we delete. Once the pod got deleted, Kubernetes not creating another pod and application went down. So not accessible. So if you want to achieve high availability, then we should not create the pods manually. We should not create the pods manually. We need to use the Kubernetes components to create pod. Then Kubernetes will provide a high availability. So high availability means always our application should be accessible. Kubernetes components for high availability is a replication controller, replication set, daemon set, deployment, stateful sets. These all are the Kubernetes components for high availability. So high availability. What is a replication controller? So what is a replication controller? It is one of the key feature in Kubernetes. What is that, guys? It is the one of the key feature in the Kubernetes. It is responsible to manage pod lifecycle. What is that, guys? This replication control is responsible for manage the pod lifecycle. It will make sure given number of pods replicas are running at any point of time. It will make sure a given number of pods, the replica set is 3. So replicas are running at any time of any point of time. Note if any pod got crashed, deleted, dead, then replication controller it will replace it. So replication control is providing facility to create a multiple parts, and it will make sure parts always exist to run our application. Using replication controller, we can achieve high availability. So replication controller and parts are associated with labels and selectors. So how you can association with labels and selectors. So the manifest file creation. So pod manifest file, API, kind, metadata spec. So node port service manifest, API kind, metadata spec. So this is nothing but a pod and a service manifest. So manifest file, so we already know, right? What type is node port and selector. This is the most important in the manifest files. So replication controller.aml. So how you can create the replication controller.aml. So API version, so kind equal to replication controller. What is that, guys? Kind equal to replication controller. Metadata name equal to Java web app replication controller. So replicas, here you see the spec, you say you can spec specification, you can select the replicas equal to 1. So replicas equal to 1, selector equal to app Java, template equal to metadata, name Java, labels equal to app, spec containers, Java container, image equal to from here port. So node port service. So this is the replication and the labels and the selectors. Labels and the selector you can connect it. So here metadata same, spec equal to replicas 1. Spec equal to replicas 1, selector equal to app Java. So the same like as a here also we provided the selector, right? This is the selector. Selector, under the selector we need to create the template. So we need to create the a template, guys. 1 second. Yeah, guys. So we need to provide the replicas and the template. So template equal to, so template means this template is for the replication controller. This template is for the replication controller. I will show you guys. I will show you. So pods, services, namespace. As of now, we have created the pods manually using the pod manifest file. If you want to delete our pod, Kubernetes is not recreating the pods, hence application will down. Right, guys? So how you can create? It is not all recommended. It is not recommended to create the pods manually. Always we need to create the pods using the components, Kubernetes components, right? Replication controller, replication set, deployment set, stateful, and daemon. Guys, a replication controller. So first one is a replication. It is a Kubernetes component which is used to create the pods. It will make sure always given number of pods are running our application. It will take care of the pod life cycle. When pod is crashed, damaged, deleted, the RC will, replication controller will create a new pod. So we can scale up, scale down the pods count using the replication controller. So what is that, guys? A replication, a controller. Same we can take this. So we can take this what is that, pod SVC, right, guys? Yeah, replication controller. So here is our replication controller. Yeah, guys. So this is the selector, node port selector, nginx target port, node port, right? We need to provide the node port here. So copy. So we can try with a new one, guys. So we can try with the namespace hyphen pod hyphen svc hyphen replication controller dot yaml. So replication control dot yaml. I'm creating this one. So this is the API version, right? So so we need to create the, so here I'm giving this, and here I'm creating a node port, node port. The node port is 30222. I'm giving the node port for the, so then, so here how many, guys, created, right? Yeah. So here we can create the, namespace, namespace equal to, so nginx web app ns. You can create nginx web app ns namespace. So here also, yeah. So first we can creating the namespace. So the namespace is, you guys are better understood about the REITNS, REITNS, the, yeah, here, guys, here. So we created the namespace REITNS in the API version v1. So pod, guys, we don't use the pod, just you can use the replication controller. So replication controller, so metadata, so name equal to, so nginx web app rc, the name equal to nginx web rc, namespace. Here we need to provide the namespace. So what is the namespace, guys? Hari ITNS. Hari ITNS. Here also we need to provide the namespace. Namespace Hari ITNS. Guys, You understood, right? So we are taking the image from the Docker Hub directly. This is the predefined image, guys. This is not our own created image. This is the predefined image. So first, so we are creating the namespace. Then we are creating the replication controller. So replication controller means, so in the replication controller, if any pod deleted, so if any pod is deleted, it automatically creates, guys. So replication controller metadata nginx web the name nginx web app rc means replication controller. So namespace. So what is that? The so kind replication controller. So we need to create the spec for the replicas. So this is the replication controller. The specification for the replication controller and the specification for the container. So what is the specification for the replication controller? The replication controller replicas 3 high availability. If any pod crash, delete anything, the 3 pods, it automatically creates 3 pods. So what is the selector? So selector equal to app nginx web app template equal to. So we can specify in the specs replicas selectors templates. So we can select replicas selector a template. So we can create the a template. So we can create the a template, guys. Guys understood? So this is nothing but a namespace pod svc replication controller, guys. Replication controller. Let's check it, guys. Okay. So va shit va namespace va rc hyphen pod hyphen svc hyphen ns dot yaml. Guys understood? So here, so we are creating the here first we are creating the namespace. No, guys. Yeah, first we need to copy, paste it. So API version namespace Hari IT ns the replication controller and the replicas equal to, yeah, guys, this is most important, replicas equal to 3. So the selector and the templates, we can create the selector here and the template. This is nothing but a node port. Let's check, guys. Yeah, guys, there is a error in the where we provided the 2018 the namespace, right? Namespace equal to ReITNs. So metadata, right? Replication metadata only we can provide. Namespace. Yeah, spec type node port to selector. Metadata ReITN is the template. Here we need to create the names. You don't, right? Replication controller is namespace. Yeah, namespace ReIT unchanged, replication controller unchanged. That service nginx is created. kubectl get parts. Under the namespace is not created. We'll show you later, guys. So, you know, vpod rc.yaml. So we're deleting this one. I'm deleting this one, guys. I'm deleting this one also. Deleted namespaces. Something wrong. Yeah, guys. I just created this is the only the replication controller. This is the only replication controller. Yeah, kubectl apply rc.yaml. Yeah, so these two are created. Kubectl delete all all, guys. I'm deleting everything. Yeah, now I'm trying to create the rc.yaml. Yeah, kubectl get parts. kubectl get parts. So -o wide. How many parts are created, guys? 3 parts are created because of the replication controller. What is that, guys? The replication controller is 3. What is that? The replication controller. What is the replication controller, guys? Yeah. So what is that? Replicas 3. 3 replicas, right? That's the reason 3 created. 3 created. 1 second. Guys, understood? So 3 created. So I'm deleting any one of the pod, guys. I'm deleting any one of the pod. So the pod is something like kubectl delete pod, delete pod. Yeah, guys. Deleted the pods. Yes, again it is deleted. The what is the IP address of the we deleted, guys? 52 is deleted. Now we created the 208. It's created under the 116. So two pods are created under the 37 node. Two pods are created under the 37 node. This is the 116 node. So this is the 37. So two pods are created under this node, and one pod is created under this node, guys. So one pod is created under this node. So if we delete the pod, it automatically creates, guys. It automatically creates. You see. So 5 seconds ago it's created. So 5 seconds ago it's created. 53 seconds ago it created. Guys, understood? So this is nothing but a replication controller. What is that, guys? Replication controller. So kubectl get svc. So node port is right. Node port is 3022. Let's check, guys. 30222, right? I think security group is not enabled, guys. Yet security group is not enabled. Let's check this one also. Yeah, 322. The security group is not enabled, guys. That is the reason. Otherwise, it come rise. Guys, now you understood the replication controller? Guys, understood or not?
Yes, sir.
Okay. So tomorrow we will tell you replica set, guys, the replication controller and the replica set also we can tell. So a replica set is a replacement for the replication controller. It is a next gen component in the Kubernetes. So what is a replica set? It is the next generation of a replication controller. It is also used to manage the pod life cycle. So we can scale up and scale down pods using the replica set also. The only difference between replication control and replica set is a selector support. So we have two types of selectors, equality selector and set based selectors. So examples of the equality and set based selectors are, so equality selector is the replication controller. That set based selectors are the replica set. Selectors match expressions, key, operator, values. So we will provide it, guys. The replication control versus replica set in Kubernetes. So Kubernetes replica sets, it can be considered as a replacement or a replication controller. The replica set and the replication controllers, key difference is the replication controller only supports the equality based selector, where the replica set supports the set based selectors. Set based selectors. So we'll show you guys tomorrow. So we'll show you. So daemon set. So what is a daemon set? Pod creation, deployment, strategy, recreate, rolling update, blue and green. So we'll show you tomorrow, guys. Okay. Most probably we'll complete the replica set and the daemon set and the Kubernetes components. Okay. Thank you. Guys, speak out, guys. Why are you sending the messages? Okay. Yes, understood, right?
Okay.
Nice.